The topic of this video is building linear models from verbal descriptions. Let's look at a problem. Suppose that a company has just purchased a new computer for $1,600. The company chooses to depreciate using the straight line method for 4 years. Part A. Write a linear function that expresses the book value v of the computer as a function of its age, x. Part B. What is the implied domain of the function? Okay, before we begin solving this problem, let's talk about the idea of book value. You've probably heard the idea that when you purchase a car brand new, the moment you drive it off the lot, it immediately loses value. This is the idea of book value. So if you want to know how much something is worth and it's no longer brand new, it is very likely that there is some sort of a reference source. In older times, we would use a book for that. Today, we would probably use the internet that will tell you the, quote, book value of that particular item. So how much is a 1998 Honda Accord worth today, for example? So that same idea can be applied to other things, such as computers. When you buy a computer brand new, pretty soon, in about 2, 3, 4 years, that computer will be worthless. You won't be able to give it away. And so being able to model the value of a computer is something that's very important to be able to do, particularly for businesses when they need to figure out the value of their business for tax purposes. They need to figure out how much their machinery is worth. This process is going to help us with that. Okay, so with that all said, let's go ahead and jump into this problem. First of all, we're using the straight line method. So what that means is we're going to create a graph here. We're going to label the graph with the two variables. So x is going to represent the age of the computer, and v is going to represent the value of the computer. We know that when we buy something brand new, the value is $1,600, and we know that it's going to last for 4 years. So that allows us to create our graph very easily. And it's called the straight line method because we're going to draw a straight line between these two data points. So get out your straight edge. Remember, lines, line segments, and rays have to be drawn with a straight edge. This is a line segment. So there is our graph. Now let's label the points. So the coordinates of this point right here is 0, 1,600. The coordinates of this point is 4, 0. And let's talk about what this means. Remember, x represents the age. So I'll label that here. The y, or the vertical coordinate, in this case v, represents the value. So I'll label that right here. So we can see exactly what's going on in this problem. When you buy a computer brand new, its age is 0. You haven't even had it for a year yet. It's brand new. And its value is what you paid for it, $1,600. However, when the age is 4, when 4 years go by, it is worthless and the value is 0. And the government allows us to draw a straight line between these 2 points to make the math a little easier so that we can estimate the value of various devices for tax purposes. Okay, so write a linear function. That means if we can just come up with an equation for this line, we will have achieved the goal here. Write a linear function. So how do we come up with the equation of a line? Well, it's pretty simple. In order to write the equation of a line, you need 2 things. You need to know the slope of the line and a point on the line. So let's see if we can get the slope first. So the slope of this line, m, is equal to y2 minus y1 over x2 minus x1. Of course, in this problem, there are no y's. Everything is actually in terms of v. So I'm going to change my formula here to be v2 minus v1 over x2 minus x1. And we can label our points here. So let's say that this is x1, v1, and this is x2, v2, so that we can plug into our formula. So v2 is 0 minus v1 is 1,600 over x2, which is 4, minus x1, which is 0. So this is going to give us negative 1,600 divided by 4, which is negative 400. So there we go. We have our slope. The next thing we need is a point. And we learned in a previous video that if you're able to pick a point on your line that has an x-coordinate of 0, you should, because that makes it a y-intercept, and it makes it very easy to write the equation of your line. So our y-intercept b is 1,600. So this is m, and our y-intercept b is equal to 1,600. So writing the equation is very easy. You just have to remember y equals mx plus b. We know that m is 400, so we can replace this m here with 400. We learned that b is 1600. Excuse me, negative 400, I apologize. Get that negative in there. We know that b is 1600, so I can put that over here. So here is the equation of this line, y equals negative 400x plus 1600. I will change this y to v because that's the variables that we're dealing with in this problem. And because it says as a function of x, I'll actually write it as v of x. So there we go. Now we have made our linear function. Okay, that brings us to part B of this problem. What is the implied domain? Well, we can see just by looking at the graph that the only possible values for x are from this spot to this spot. This is a line segment. It starts and ends at these 2 points. It doesn't continue over here. It doesn't continue over here. So the values of x that we're allowed to use have to be the values of x that are in between these 2 points. So what's the x value here? 0. What's the x value here? 4. So what's the domain? 0 to 4. So our domain for this problem will be 0, 4. Now let's talk parentheses and brackets for a moment. Is it possible for a computer to be exactly 0 years old? Yes, the moment you buy it. Therefore, 0 is a possible x value. Therefore, it belongs in the domain, and we would use a bracket. Is it possible for a computer to be worthless at 4 years old? Yes, of course that's possible. So 4, which is an x value, belongs in our domain, and therefore we use a bracket at 4. All right, with that, we have answered both parts of this question, and we are done with this problem.